All right, today we're going to move into lesson 9.5 on trigonometry. The objective today is solve problems using the trigonometric ratios and the inverse ratios. And when we do use these trigonometric ratios, we're going to work from the acute angle in a right triangle. All right, so trigonometry, if you look at the definition, it comes from the Greek word uh, trigon, which means triangles, a metron, which means triangle or means measure. So trigonometry is the word that's made up is to find angle measures in triangles. A trigonometric ratio is a ratio of two lengths of the sides of a right triangle. So when we use our trig ratios, the numbers used in those ratios come from the side lengths of triangles. And then our three most common trig ratios are sine, and the sine is the ratio of the side opposite to the acute angle to the length of the hypotenuse side of the triangle. So we write it like this: sine, and this is theta. I'll talk about that in a second. This is the angle. So sine of theta equals opposite over hypotenuse. The second one is cosine, and cosine is the ratio of the side adjacent to the acute angle we're working from to the length of the hypotenuse. So cosine, which is just the cos of theta, this is the angle again, is equal to adjacent over hypotenuse. And then finally, tangent is the third of these three that we use prominently. This is the ratio of the side opposite the acute angle to the length of the side adjacent to that acute angle. So tangent of theta looks like this: opposite over adjacent. Okay, now this whole theta uh, deal here that you see in these expressions is taking the place of the acute angle in our triangle. It's a Greek letter. It's used a lot in trigonometry and geometry in general. But it's right now that when you see this Greek theta, that's representing an angle measure. Let's show you how that works in a second. All right, so this first example, find the sine of j, cosine of j, tangent of j. Now they're saying of j, they're talking about this angle j, which is an acute angle of a triangle. We're also going to find the sine of k, cosine of k, and tangent of k. K is this angle in the triangle, this acute angle inside the triangle. We're going to express each of these as a fraction and as a decimal to the nearest hundredth. I put this in here, SOHCAHTOA. You've probably seen it before. It's just an acronym for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite of adjacent. People memorize it, write it on their paper, and then it helps them remember how the ratios work. All right. The first thing we need to do before we get started with these trig ratios is identify the sides. So you saw us in the examples talk about opposite, adjacent, hypotenuse. That is dependent upon the angle you're working from. So let's say that we're going to start working from angle J first. So J is my theta. That's the angle I'm working from. All right. From this, we need to name the sides from angle J. So the first thing you always know is the hypotenuse is the side across from the right angle. That's no big deal. Okay, the side across from the angle you're working from, your theta, which is J, this side is called the opposite, and then the remaining side is adjacent. So from J, 13 is opposite, 5 is opposite, 13 is the hypotenuse, and 12 is the adjacent side length. So these are the numbers that correspond to those different terms. So sine of J is opposite over hypotenuse. So opposite is 5, hypotenuse is 13. So we're just going to say sine of J is 5 over 13. And if we write it to the nearest hundredth, it'd be 0.38. Cosine is adjacent over hypotenuse. This is cosine of J. Adjacent is 12, hypotenuse is 13. So that's 12 over 13. That's 0.92. And then tangent of J is opposite over adjacent. That's 5 over 12. And if I did the division there, it'd be 0.42. Okay, so that's the first set of three they ask us to find. These are the ratios, and these are what the ratios are as decimals. Now we're going to do the same exercise, but we're going to do it for angle K. So I'm going to get rid of everything up there. And now K is going to be my theta. So again, we name the sides from the angle. So again, hypotenuse is always across from the 90, so that doesn't change. But now opposite is going to be the 12 because that's the side opposite of the K, the theta. And then that makes 5 now my adjacent. So these two have switched positions or switched labels. But we're going to use the new labels though, and we're going to find the sine of K. So that's opposite over hypotenuse. Opposite is 12, hypotenuse is 13. That's 12 over 13, which is 0.92. Cosine of K is adjacent over hypotenuse. That's 5 over 13. That's 0.38. And then finally, tangent of K is opposite over adjacent. So that's 12 over 5. And that's going to be 2.40. If we had to go to the nearest hundredth, it'd be 0. Okay, so that's our trig ratios for a right triangle working from both of the two angles that are there. Now, how do we use these to help us solve problems? All right, so the instructions here use the trig ratios to estimate the lengths of sides EF and DE and round our answers to the nearest hundredth. So as you look at this right triangle, 23 is the hypotenuse, but we don't know DE, we don't know EF, so we really have no way of finding those two using our traditional math, like Pythagorean theorem, for example. I don't have enough information, so we're going to use trig. Okay, so the first thing I want to do is label the sides so I know what I'm talking about. Now 53 is going to be the angle we work off of, so there's my acute angle. All right, so that means obviously DF is the hypotenuse. Side F to E is going to be my opposite because that's the side opposite of the 53, which is what we're going to work from. And that leaves DE to be adjacent. So I'm going to work from the 53-degree angle. These are my labels. Now I got to find the lengths of these sides. I'm going to start by finding FE first. All right, so the way you pick your trig ratio is this. FE is opposite, and we know the length of the hypotenuse. So I want to use the trig ratio that uses opposite and hypotenuse, and that would be sine. So I'm going to use the sine trig ratio, which is opposite over hypotenuse. Now I'm take this statement, I'm going to replace what we know. We now know theta though. That's 53 because I'm working from the 53-degree angle. FE is opposite and 23 is the hypotenuse. So now I have this equation that I need to solve. I want to isolate, find FE. So I'm going to multiply both sides by 23. That will cancel out that denominator of 23. And I'll have FE equals 23 times the sine of 53. Now, if you go to your calculator and you push the sine button and enter 53 and then hit equals, it will tell you the numerical value for the sine of 53. And then that answer times 23 is our answer, 18.37. Okay, so that's finding FE. All right, now find DE. Well, DE, going back to our drawing here, DE is the adjacent side. So now I want to use the trig ratio that uses adjacent and hypotenuse, and that would be cosine. So again, we're working from the 53-degree angle. That's adjacent, that's hypotenuse. So fill them in here. Theta is 53. DE is adjacent. Hypotenuse is 23. So here's my equation. I need to solve it to find DE. So again, we'll multiply both sides by 23 to cancel out that 23 in that denominator. DE is 23 times the cosine of 53. If you push the cosine key in your calculator, enter 53 after that, hit equals, it will give you the numerical value for the cosine of 53. Multiply that by 23, and DE is about 13.84. So those are the lengths of those two sides. FE is 18.37 and DE is going to be 13.84. We found those lengths using the trig ratios. Okay. If you wanted to double check to make sure you did it right, this is going to be Pythagorean theorem here. So if you did 18.37 squared plus 13.84 squared, it should equal 23 squared. It won't be perfect. It won't be exact because we rounded these two, but it's going to be pretty close. Okay. So that's how we use trig. Let's do it again just to make sure we get the gist of it here. So now I'm going to find the lengths of AC and I want to find AB. Okay. So the first thing is they give us the 65-degree angle. So I'm going to work off of that. So the first thing we do is identify the hypotenuse that's across from the right angle. AC is going to be opposite because it's opposite of the 65 degrees, and that leaves the side that's labeled 4 to be adjacent. Okay, so we got to find AC and AB. Doesn't matter which one you do first. I'm going to find AC first, opposite. So I'm given adjacent, that's 4. I want to find opposite. So which trig ratio uses adjacent and opposite? Tangent, opposite over adjacent. Again, my theta is going to be 65. So tangent of 65 equals AC over 4. Okay. Now we want to solve this thing for AC. So we're going to multiply both sides by 4. That cancels that denominator out. AC equals 4 times the tangent of 65. Again, if you go to your calculator, hit tangent, enter 65, hit equals. It gives you the numerical value. Multiply that by 4. And AC is about 8.58. So this distance is 8.58. Okay. Now I want to find hypotenuse. So I want to find AB. So AB is the hypotenuse. We know 4 is adjacent. Now, I'll just to say this quick, I would not, you could use opposite to be 8.58 and then, use the sine ratio opposite over hypotenuse, but 8.58 is rounded. So if we use it in another problem, we're going to compound that error. So I would not, I would go back to the 4. I'm going to use cosine of theta is adjacent over hypotenuse. Again, 65 is the angle we're working from. 4 is adjacent, hypotenuse is AB. I wanted to show you this one specifically because if you notice the AB is in the denominator now and I have to solve for AB. So we're going to have to multiply both sides by AB. It's just a number, remember. That will cancel out this denominator of AB. It'll move AB to the other side. And now to get AB isolated, I got to divide each side by cosine of 65. So in your calculator, you got to be careful when you do this. So you're going to go 4 divided by, and then I would put parentheses, cosine 65. Make sure you use the right number of parentheses afterwards so that you get it in your calculator correctly. The answer to that, though, is 9.46 when you do it all. Okay, so the distance from A to B is 9.46. So again, that's how we use trig ratios to find side lengths. Okay, now we're going to talk about the inverse trig ratios. And every mathematical operation has an inverse, right? The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of squaring a number is to take the square root of the number. Well, the inverse in trigonometry is exactly what you think it is. It's the inverse of the function. So inverse is going to be, and you guys should remember this, when we have a base to a negative exponent, that means write it as 1 over that. So sine to the negative 1 is really 1 over sine. And when you multiply 1 over sine by sine, they're going to cancel out. So this is the inverse. And if you look at your calculators, this is usually above the sine function as a second process in your calculator. So anyway, the sine inverse is going to look like this, sine to the negative 1. What that means is if my variable, if my unknown is the angle, so I'm saying sine of A equals X, X is some number, and I want to get A, then I'm going to multiply by sine inverse. The sine inverse of that value will tell me what the angle is. And it's easiest to see in an example than it is for me to try to explain it this way. So we have a sine inverse, we have a cosine inverse. This will undo the cosine function, if you will. And we have a tangent inverse. Oops, I should say tangent inverse. We have a tangent inverse that will undo the tangent function. Okay, so we have an inverse for each of those 3 that help us solve when the unknown is the angle. And those you should be able to find on your calculators. Now let me show you how it works. Okay, so they're asking us to find the measure of angle A and B. Notice now we're given 2 side lengths, but we don't know the measures of angle A and B, but we know it's a right triangle. Okay, so we can use our trig ratios to figure out the measure A and B. So let's find the measure of angle A. So we're going to find the measure of angle. That means our theta, as we work off of this, is angle A. So if I, again, assign the names to the sides, that's always the hypotenuse across from the 90. 12 is going to be my opposite, and that leaves AC to be my adjacent. So when I want to find this angle, I got to use a trig ratio that has 2 numbers in it so that I can work with those 2 numbers. So I want to use opposite and hypotenuse in this case to find angle A. So I'm going to use sine. Sine of theta equals opposite over hypotenuse. Now, I'm going to replace theta with angle A. So the sine of A is equal to 12 over 20. Now, here's where we use sine inverse. A is what I'm trying to get. I'm trying to solve for A. So I need to eliminate that sine function. So I'm going to take the sine inverse of the sine of A. And that sine inverse will cancel out the sine and give me measure of angle A. And then in your calculator, you're going to do sine inverse parentheses 12 divided by 20, close parentheses, hit equals, and it will tell you that that angle is 36.9 degrees. If this is a right angle, that length is 12 and that length is 20. This has got to be 36.9 degrees in order for this triangle to be a right triangle. That's how it works. Okay, now let's find the measure of angle B. So I'm going to start from scratch. I'm going to eliminate all this up here and I'm going to restart. We're going to go from angle B now. That's my theta. So I got to rename my sides. There's the hypotenuse. AC is opposite and BC is now adjacent. So to find angle B, I got to use a trig ratio that uses adjacent and hypotenuse. So that would be cosine, adjacent over hypotenuse. I'm trying to find angle B. So in place of theta, I'm going to put B. Cosine of B is 12 over 20, adjacent over hypotenuse. Cosine inverse will cancel cosine. So I take the cosine inverse times the cosine of B. That will cancel. And the cosine inverse of 12 over 20 is about 53.1. Now, I will tell you this. What you know in this right triangle is A and B have to add up to 90. Okay, if that's a 90 and all three add up to 180, then these two add up to 90. So really, once you have one of those two angles, let's say once I knew angle A was 36.9, I could have just subtracted from 90 to get 53.1, but I wanted to show you how it worked with trig. So you have that. Okay, last thing we're going to look today is how we solve a right triangle. You'll get this instruction, solve the right triangle, and all that means is you got to find any missing side length, any missing angle measure. And we're supposed to round everything to the nearest tenth. Now I'll say here, when you're asked to solve one of these, you can use trig, you can use Pythagorean theorem, and you can use the triangle sum theorem. I would use all of these. Okay, you don't have to do it using all trig. In fact, if I'm finding AB in this triangle, well, I got to find that side length. I'd use Pythagorean theorem for starters. A squared plus B squared equals C squared. 7 squared 4 squared equals AB squared. AB squared equals 65. Square root of that is about 8.1. So I know the distance from A to B is about 8.1. That's first. Okay, second, I got to find one of my angles. I'm going to find angle A. I'm going to call that theta. Okay, now label the sides. That's hypotenuse. There's opposite. Man, that leaves this to be adjacent. So to find the angle, I got to use the lengths of the sides I know. Opposite, adjacent. That's tangent. Opposite over adjacent. So tangent of A is equal to 4 over 7. How do we eliminate tangent? Tangent inverse. Tangent inverse will cancel tangent. I'll have angle A. And the tangent inverse of 4/7 is 29.7 degrees. I will tell you, when I go to find B, I'm going to use the fact that I know A and B add up to 90. Once I have A, I know B is 60.3. So to solve this right triangle, I had to find AB, angle A, and angle B. Now all parts are accounted for in terms of their measures. Okay. One more of these. Okay. This time you have the angle in one side. They always have to give you two, an angle and a side, two angles, or two side lengths to be able to do these. Okay, so where would I start here? I would find A. That's easy enough because I know A plus B's got to be 90. So A's got to be 42. So I know this is 42. Now I'm going to label the sides working from the 48-degree angle. Now you could work from the 42 if you felt like it. You'd have to relabel it different. And then when you go to use your trig ratios, you'd use 42. But I'm going from the 48. So that would make this opposite and that would be adjacent. Okay. So I'm going to find AC first. Okay. AC from the 48-degree is opposite. Adjacent we know is 11. I got to use a number that I know in here. So I'm going to use tangent, opposite over adjacent. Tangent of 48 equals AC over 11. Multiply each side by 11. AC is about 12.2. So I know this distance is about 12.2. Okay. Lastly, I'm going to find AB. So AB is my hypotenuse. Okay, I'm going to use trig to do this. So I'm going to work from the 48, hypotenuse, adjacent. Those are the two I need to work together. That's cosine. Cosine of 48, 11 over AB. This is another deal where AB is in the denominator. I'm going to multiply each side by AB to get it out of the denominator. That'll give me AB times the cosine of 48 is 11. Divide each side by cosine 48. And AB is about 16.4. So that gives us all three missing parts there. So tonight your homework is on the McGraw-Hill site. I think there's 15 questions, but it's trig ratios and applying a little bit of what you know that we talked about today for trig ratios. So, write things down. Make sure you have a calculator handy because you're going to be asked to round and get answers down to the 10th or the 100th. Okay, make sure you write things out. Take your time. Do it correctly.